Hello, everybody, and I would like to welcome you to this video from iOS Tutor. And today we are going to do Class 12 Electric Charges and Field Chapter 1. I am very sorry for the delay, and I just need 1 minute of you guys. Like just 1 minute. I just need 1 minute. I just need to tell you some two things. Number one is, as you guys remember, I'm uploading this video after I guess 10 months or so. So I am beginning with class 12th, then class 11th because I wanna, give you the content that you are currently studying. I'll try to. I don't think I'll be able to do class 11th by the time you guys clear it, but I'll be able to put it on my channel if you guys wanna check it sometimes. See, the thing is, people have like physics wala sir, one of the best teachers I know. I support him totally. If you guys don't want to watch me and want to watch him, that's cool. I just try to explain it with the way I understood. See, I am a student right now. I'm studying in college right now. I'm doing Master of Physics. So basically, I am just trying to explain you the way I see it. I guess many people do it along with me. So it's just a vision to help you guys understand it the way I thought my teacher would explain me. I would have done it very better. So before I'm gonna take the help of SL Aurora book. If you guys don't know this book, it's called SL Aurora. If you guys know, that's very amazing. After so much of your requests and all, I'm continuing this series of SL Aurora. You have to put in, thank you so much for your love on the first video. I was really shocked to see that. So, without wasting any further time, I'll start up with the chapter. Uh, First of all, I would like to talk about electric charges. Before we start, we don't need to cram this chapter. I don't want you guys to cram it. It's a very, very amazing chapter. You're gonna like it a lot. Electric charges and if you guys want this PDF of what I'll make, because my writing is not that good, so if you guys don't like it, then I'll be sorry for that. But if you guys do like it, then let me know and I'll share you the PDF. Okay. So first of all, we are going to talk about electricity. What is electricity? Electricity. Okay. Basically, what is electricity? Like if you go to your room and you just go and you turn the switch on and you just see the bulb lighting up. It's a very basic example. You must have always heard it, right? So that's electricity. But electricity can be of very different types. The electricity that you see, that's like man has made those tools like wires and all, like a person has done it. It didn't exist before. We didn't know that if like we'll connect the wires and all, then a bulb will start. Man constructed through experiments and all the appliances. Like so that means electricity can be appliance derived, or it can be non-appliance derived. See, this is not in the book or anything. That's how I have seen electricity, and if you write it, your teacher won't cut it because this I have read in some books that that is not from SL Aurora, that is from some other place. Okay, so basically, appliance derived is something like, see, man-made. What do you need to for a bulb? Let's say we have a bulb. For a bulb to start, like we have this bulb and this is the coil. Okay, so for it to glow, what do we need? First of all, we needed to make this bulb, right? सबसे पहला this bulb we had to make. Then we had to wires. The man had to make the wires. Then man had to make the cell. See, if neither the cell existed, nor the wires, nor the bulb, would we get this light? No. So the thing is, this is derived. Humans made these appliances. They thought and everything, all the processes went in to develop this thing, and that's how we got our lights, right? So cell derived, or there can be other also, like right now, what do you know? Nuclear. See, the thing is, if you guys are looking for like you wanna understand like just read and do. I don't want to do that. I want to explain you from the ground, like what is electricity. This chapter will be long. This is just the part one. Okay, today we are just gonna cover what is electricity and like basically what are charges and what are the types and what are the types of charges and what are its properties. That's whole what the chapter is about. If you guys wanna really enjoy it, like you wanna learn what's a fucking charge, like you wanna learn it. I'm sorry for the words. So yeah, you're gonna like it. Okay, so then there's non-appliance derived, but I promise you, this is all CBSE and other boards also, whoever boards like it. So not appliance, right? It like basically doesn't mean it doesn't require an appliance because you need an appliance to bring to see the electricity. But it's basically it just even the natural materials on Earth, like they can be electric or non-electric, like or like I'll explain you. For example, we have how do I explain you? Okay. So, for example, you have a scale. Okay. Yeah, you must have done it in your school. Static charges, we'll call it static electricity here. So, static electricity. So, what it is? So, let's say you had a scale, and this is your head. And what you did, you took the scale and you rubbed it. What you did, you rubbed it. And when you rubbed it, and then you took some papers, these are papers, and like when you took this scale close to these papers, what did you observe was that these paper, they get attracted, or they tend to get attracted. But if you apply oil, if you apply more oil, what you do is you increase the conductivity. When you apply oil, you increase the conductivity, and then when you touch it, the soap, they tend to attract faster than when you didn't apply oil. So oil here acts as a conductive increasing agent, which increase the conductivity or increase the staticity or the like the static electricity increases because it increases the amount of rubbing. It increases the amount of when you the electricity produced by rubbing. See, oil is very it's good. It helps to attract it. So this is like a static electricity, or you can call a frictional electricity. So this is also called friction. That is friction electricity, the electricity that is produced by friction. You guys must have learned it in your 11th standard. What is friction? Friction is like when we rub two bodies against each other, like let's say these are two bodies, and when we rub it against each other, we produce energy or we produce heat or energy, like anything you can call Q or delta H, whatever you guys like to call. So, yeah, that's basically all about electricity. Basically, what is electricity? What the hell is electricity? I guess you got an idea. Now, what is the agent that causes electricity? What are the agents? Agents are these small particles, and basically these are called electrons. So the particles which cause electricity are called electrons. So let's say now we have to understand, we have to go deep, okay? So we'll go to the book now. We'll start reading from the book so as to understand it. So see, here I have cleared you what's the frictional electricity and I've cleared you what's electrically charged like, okay? So what is an electric charge? What is an electric charge? Is it scalar or vector? Scalar or vector? If you guys want me to make a video on vectors, just let me know. I'll make a video for you on vectors. Okay, so electric charge. Electric charge is an intrinsic property of elementary metals like particles, sorry, like electrons, protons, etc., of which all objects are made up of. Okay, so that's a very easy definition for you to understand. I guess it's all written in the book, basically. But the thing is, my work is to explain you. So let's start. What is an electric charge? Basically, we need to understand what is an electric charge today. That's my main aim today to come. From the next class, I'll try to increase my speed. Today, this is just an introductory lecture for you to get used to what is an electric charge. So electric charge basically is a property. Charge is a property. It's like property. For example, metals, they have lust. Lust is a being lusty is their property. Okay. And for example, shiny. Metals are shiny. They tend to be shiny if they are rubbed. Like if they are greased or if they are like rubbed properly, they tend to be shiny. Metals are tend to form positive ions. So that's a property. The metals, they form positive ions. That's a property. So same way, the electrons, it's the property of electrons. It's the property of electrons. A charge, it's a property of electron, proton. Basically, proton also is responsible to give electric charge, of which all objects are made of. Let's say, for example, you, me, you, the phone you are seeing this on, the laptop you are seeing this on, the books you see. We have learned it in LKG. Oh, not LKG, but yeah, like let's say eighth or ninth class or seventh class maybe. That we all are made up of matter. We all are made up of matter, right? And the matter is made up of molecules, right? And molecules are made up of atoms, right? And atoms are made of protons, protons, neutrons, and electrons, right? And these protons are further made, and these neutrons are further made of quarks. All these. Also, there are many myons, pions. If you go this ahead, it goes to particle physics. If you guys are interested to know, you can always look on Google uh, particle physics. This goes ahead from after this. You learn this in your college, like what are these quarks and all, what are myons, what are pions, like for example, the protons, they are made of two muons and one dion. So like there, if you check the structure of a proton, that's no teacher is gonna tell you. I can tell you. So there are two muons and one dion, and they are like connected with these glycine strings. But it's really you guys don't need to go that deep into it. Basically, what I'm trying to tell you is like these properties that they show, these electrons show, these protons show, they show these properties of charge. That's called it's a property. Okay, so electric charge is an intrinsic property of elementary particles of matter which gives rise to electric force between various objects. So basically, the charge, so what can we conclude? An electric charge is responsible for bringing force. So electric charge can bring force. And what kind of forces are these? We'll learn ahead. You basically already know it. Attraction, and the second is repulsion. Okay, so let's come back to the book. So that's it. Now we need to, this is some theory that is helpful for your exams. Okay, so electric charge is a scalar quantity. Oops, sorry. Yeah, electric charge. Oopsie, I have to make it a little big, I guess, so that it's better. And okay, second, and I have to take this. So yeah, electric charge is a scalar quantity. So electric charge is a scalar. Whatever I underline with this stylus, and that's this will be the most important thing that can come in your MCQs or somewhere else. So the SI unit, that's Coulomb. Coulomb will talk about it. Don't worry, guys. I'll explain you. I am just not gonna read the theory like your teachers. I'm gonna try to put it in your head also. So a proton has a positive charge. I guess, I hope so. You all know this. So that's why I'm not getting deep into it. And an electron has a negative charge. That's electron. So guys, basically, I'll tell you one thing. The movement, okay? You know what's the cause of electricity? I'll tell you one thing. You'll learn it with me. The movement or the potential difference, potential gap, let's say. between protons and neutrons produces current. So, see, basically, when a bulb lights, if this is a bulb, when it lights, the charge it gets, right? The this it gets. It's basically not this electricity. It's like basically this is current that flows. No, sorry. This is electricity. This is electricity. Okay. But the thing, all of this that flows in this wire, then it reaches the layer. That's called current. That's the thing. There's a difference in both these things. Some people never tell you this. There's a difference in this. The current is the flow of electron. Like for example, there are electrons in this. They're trying to go. They always flow opposite to the direction of current. So the electrons try to flow opposite, and the protons are marking with yellow. They try to move in this direction towards the light. Okay, and the friction that happens, and the friction. Oh, sorry. And the friction that happens, and you guys, the friction that happens that produces current or charge in the not charge, current or electricity. Okay, so that's the thing. Basically, current and then electricity. So friction produces current, then produces electricity. So I guess now you know what's the basic thing. How does the light happens? Like when we turn the light, what happens? So okay, one more question that comes in paper. It's a very important question that comes in your exams, or it's like a PYQ, or like it's important. Okay, so they say like when you like this is the bulb and this is the wire and this is like, let's say, the switch of your house. Okay, so it says as soon as you press the switch, the light comes in the bulb. Okay, how is it possible? Like, it must take time to travel, right? So what's the basic process here? Like, how does it the when you just press it comes? So the thing is, see, the electrons are already present in the wire. They are already present. They are like present long in the wire. Okay. And as soon as I press this button, what happens is the potential difference between these 2 points, the difference between the 2 points, potential difference. It's like, you can explain it like, see, if there's a, like, what do you call it? It's a pipe, okay? And what happens is if I put water, water here, okay? If I put water here, okay? And if I press the pipe, if I bring pressure here, okay, so what will happen is you'll see it'll start sucking up some water, you know, it'll start sucking up some water. I'll create some pressure here, and to fulfill the pressure, it'll start sucking up some water. It's the same thing. Potential difference is same thing. It's like building pressure on these points so that the electrons, they have to, like when we turn it, the electrons have to start moving. Basically, thing is they have to start moving into either left or right. So when they move left or right, they develop friction with the protons, and then that produces the light. So since they are already present, the electrons are present in the wire already. So the process makes it very, 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 very fast. Okay. So now you need to learn the charge on an electron. What is the charge on an electron? So the charge on an electron is 1.6 into 10 raised to the minus 19 Coulomb. So that is the thing you have to learn. This is experimentally proved and we can't do anything about it. Okay, so I'll clear this page in one go here in short. Okay, so see what now let's come here. Okay, so I'm gonna just tell you one very amazing thing that you're gonna really like. Okay, so let's say we have two rods. Okay, we have two rods, and what I did was I brought a rod that has positive charge. Okay, and this slab was negatively charged. It had negative charge. Okay, that means if it has negative charge, then the dominant charge is negative. ऐसा तो नहीं हो सकता है, दैट इज नॉट पॉसिबल कि सारे चार्ज नेगेटिव हो, मतलब उसका जो डोमिनेंट चार्ज है शायद वो नेगेटिव है. ओके, सो डोमिनेंट चार्ज नेगेटिव है. सो क्या होता है, जब मैं प्लस वाला पास लेके आता हूँ तो इसमें क्या होता है, जो प्लस वाला है, तो यहाँ पे क्या होता है, ये पार्शियली चार्ज हो जाता है. व्हाट हैपेंस इज कि ये पार्शियली चार्ज हो जाता है. दैट्स द थिंग. सो जब मैं प्लस वाला लेकर आता हूँ तो इस केस में क्या होता है गाइस, जब मैं प्लस वाला लेके आता हूँ तो जितने भी नेगेटिव चार्जेस है वो इस साइड पे अट्रैक्ट हो जाते हैं. ओके, और जो दूसरी साइड होती है वो सब पॉजिटिव चार्ज ले. तो जब मैं कोई पॉजिटिव मटेरियल को पास ले आता हूँ, अगर मान लो अब मैं इसी चीज में नेगेटिव मटेरियल को पास ले आता, और मान लो ये वाली रॉड में पॉजिटिव चार्ज डोमिनेटिंग है, राइट, तो जो इसका नेट चार्ज होगा, मान लो पॉजिटिव चार्ज उतने नहीं थे, राइट, मान लो पॉजिटिव चार्ज सिर्फ इतने थे और वो ज्यादा थे, तो जो ये नेट होगा ये नेगेटिवली चार्ज डॉट बन जाएगी. और अब अगर इस केस में देखो, अगर यहाँ पे नेगेटिव चार्जेस है और मैं इसमें लेके जाता हूँ और मैं इसको पास लेके जाता हूँ, तो यहाँ पे सारे पॉजिटिव चार्जेस इकट्ठे हो जाएंगे और दूसरी साइड पे नेगेटिव चार्जेस इकट्ठे हो जाएंगे. सो दैट्स द थिंग. बेसिकली असलियत में ये मूवमेंट नहीं हो रही है. अगर मैं इसके बहुत डीप में जाकर आपसे बात करूं, अगर मैं कंसेप्ट की बात करूं, तो बेसिकली क्या होता है, मेरी बात सुनो. देखो, मान लो ये पूरे इसके अंदर नेगेटिव 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 चार्जेस हैं, ठीक है. मान लो ये इलेक्ट्रॉन्स हैं इसकी सरफेस पे, प्रोटॉन्स भी ऑब्वियसली हैं, प्रोटॉन्स भी हैं ऑब्वियसली, मिक्स ही होता है. सो प्रोटॉन्स, न्यूट्रॉन्स, बेसिकली एटम्स हैं ये. तुम जब ये कंसेप्ट समझते हो तो इसको अगर तुम एक बड़े बड़े पार्टिकल्स के हिसाब से देखो, तो मान लो अगर ये प्रोटॉन्स है, तो ये प्रोटॉन्स कह रहा हूँ, अगर ये एटम्स हैं तो ये एटम्स में प्रोटॉन्स भी होंगे, न्यूट्रॉन्स भी होंगे, और उसके जो अराउंड घूम रहे होते हैं इलेक्ट्रॉन्स भी होंगे, राइट. सो बेसिकली यही चीज है, तो मैं बस उसका बस प्लस माइनस इसलिए लिख रहा हूँ, इसका कोई और मतलब नहीं, ठीक है. तो मान लो अगर मैं एक ऐसा मैग्नेट लेके आता हूँ, या नहीं, एक ऐसी बॉडी लेकर आता हूँ जिसको मैंने पॉजिटिवली चार्ज किया, जिसको मैंने पॉजिटिवली चार्ज किया, तो गाइस क्या होता है कि बेसिकली जो नेगेटिव चार्ज की डेंसिटी है वो इसके पास ज्यादा हो जाएगी. मतलब ये वाला चार्ज भी इधर आने की कोशिश करेगा, ये वाला चार्ज भी इधर आने की कोशिश करेगा, ये वाला चार्ज तो इधर आएगा, ये वाला चार्ज और इधर आएगा. तो क्या होगा, जिन जिन जगह से नेगेटिव चार्ज उठ के आ जाएगा वहां पे चार्ज की कमी हो जाएगी. there the charge will be less, there the quantity of negative charge will be less. And how do we represent the negative charge when it is less? We represented by a positive charge. पॉजिटिव चार्ज का मतलब क्या है, यहाँ पर नेगेटिविटी कम है, पॉजिटिव चार्ज ज्यादा है. दैट्स द मीनिंग ऑफ पॉजिटिव चार्ज. सी पीपल ऑलवेज से पॉजिटिव नेगेटिव, बट इसका बेसिक मतलब क्या होता है, दैट्स व्हाट आई एम ट्राइंग टू एक्सप्लेन यू. द थिंग इज लाइक इन दिस मटेरियल there are negative and positive charge, like there are protons, neutrons and electrons. But what happens is if I bring a negatively charged thing, so what happens is, see, the negative charges come here. अब ये वाला चार्ज उठ के इधर आ गया, ये वाला चार्ज उठ के इधर आ गया, ये वाला चार्ज उठ के इधर आ गया, ये वाला चार्ज उठ के इधर आ गया. तो अल्टीमेटली जब नेगेटिव चार्ज एक पार्ट में कॉन्सेंट्रेट हो गया, तो यहाँ पर नेगेटिव चार्ज की कमी हो जाएगी, या हियर द नेगेटिव चार्ज विल बी लेस. तो वो पॉजिटिव चार्ज की तरह डोनेट होता है, मतलब कि यहाँ पे नेगेटिव चार्ज की कमी है, पॉजिटिविटी बढ़ गई, क्योंकि नेगेटिव चार्ज तो सारा एक तरफ मूव पे हो गया था ना. दैट्स द थिंग. ओके, नाउ द थिंग इज, यू कैन आस्क मी, सर आप ये बोल रहे हो कि आप नेगेटिव बॉडी को पास लेके आ रहे हो, आप ये पर कर कैसे रहे हो, कि आप किसी बॉडी को कैसे हम चार्ज दे सकते हैं, या हम किसी बॉडी किस बॉडी को नेगेटिव या पॉजिटिवली चार्ज कैसे बना सकते हैं. So guys, it's basically very simple. I'll tell you, this is like one of the best things, like I'll tell you. Okay, तो क्या होता है, देखो, मान लो मेरे पास एक बॉडी है जिसका मुझे चार्ज नहीं पता, मुझे पता नहीं कि मेरे को इस बॉडी का चार्ज नहीं पता है कि इस बॉडी का चार्ज क्या है, और मुझे चेक करना है. फर्स्ट ऑफ ऑल मुझे पता तो होना चाहिए कि मैं पॉजिटिव बॉडी लेके जा रहा हूँ नेगेटिव लेके जा रहा हूँ। तो इसको चेक कैसे करूँ? देखो गाइस, अगर मैं एक बॉडी को प्री डिटरमिन्ड बॉडी जिसका मुझे पता है कि चार्ज क्या है, अब वो ही द थिंग इज लाइक लेट्स से आई रब माय हेड with the scale. Okay, I rub my head with the scale. Let's say I develop positive charge. We don't know which charge I develop. Okay, and I bring it close to this. So here it comes. The forces which we talked about before. What does electric charge bring? It brings a force. So if I bring it close, okay, and it develops negative charges here, so it means it will show attraction to it. If it will show attraction to it, then I'll say that the body I had, that was a positively charged body. And if it shows repulsion to it, then I'll say the body I had was a negatively charged body. It's as simple as that. Okay, guys. So let's talk more about it. Okay. Uh, huh. Okay. So I'll open the book for you guys to see where we are right now. Oh, sorry. I'll open the book for you guys to see. So basically, we did this. We did like how to determine if the body is positive or negative. Say, let's say if I bring a positively charged body and I bring it close to a positively charged glass, so the body will show repulsion. I'll know the body I had before was a positively charged body. If it attracts, then I'll know that the body was negatively charged body. Okay. Second thing is, yeah, we have done this. So basically, there can be three cases. Repulsion, repulsion. See, positive, positive, negative, 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 positive, 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 repulsion, negative, negative, repulsion. That means like, repel, alike, attract. Okay, like, repel, alike, attract. So there are only two kinds of electric charges, positive and negative. Like charges repel and unlike charges attract each other. That's the statements that we get from two kinds of electric charges. So what are two kinds of electric charges? I hope that's also clear to you now. Okay, so electronic theory and frictional electricity. All matter is made of atom consists of small nucleus. The electrons are about to this is not necessary for you guys. This is more important. What's a conductor and what's an insulator? I guess you guys know it. Conductors are which allow electricity to flow, and insulators are which don't allow electricity. So that means conductors they allow electricity. Best example for conductors is metals. So metals are good conductors. They allow electrons to flow, and insulators are like you know they don't allow. But the thing we have to learn is how do these look like? How does a conductor look like? How does an insulator look like? So I'll show you. Let's say we have metal. Okay, metal. So what happens is if I take two wires, I put their ends on it, and then I take a cell and yeah, I put it. What happens is the positive charge starts moving. It covers all the surface of it. Okay, but when it comes back to this cell to the negative charge. Okay, so basically a potential difference is created, and the charge spreads over the surface. That's how it helps. So basically, when your teacher asks you why are conductors good for electricity, like how do they? Because they allow charge to travel all over surface, all over their surface. Or a metal surface, like you can say metal surface also. See, now I'll explain you. It's like you can compare it again with water. So basically, see, I have learned this chapter electricity by considering it or comparing it with water flow. What happens when a water flows? Like, see, it'll be easy for you. You also try it. Okay, let's say this is a plate. Okay, when I pour water in it, all the plate gets the water. That means all the plate has the charge. Same is with the charge. When I allow the plus charge to flow, So it can go here, 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 here. The matter is that it's allowing it to flow all over. So it's very fast. It is easy to reach. Okay, now let's say I have a brick. I have a brick and I put water in it. Like I try to put water in it, but I'm not allowing it to go. I have barriers in front. The structure is like very bad. I'm not allowing it. There are many friction. There are many resistances. They're not allowing it my charge to flow. तो charge इधर से जाएगा, रुक जाएगा, इधर घूम के जाएगा, इधर जाएगा. So I hope you get the gist of it. This is like an insulator. Insulator doesn't allow the charge to, develop over the surface. It doesn't allow it to take on the surface. That's why insulators are bad conductors of electricity. So that's the reason. If a teacher asks you the reason, so that's the reason. Okay. So this is a very important topic, guys. You need to understand. Electrostatic induction. This I have explained you already. Electrostatic induction, the development of charge. See, he brought the positively charged glass rod, and see here all the negatively charged charge developed, and on the other side the positive. But I've explained you. Basically, what happened was the negative charge was everywhere on this rod, and when I brought this positive charge here, all the positive charges were fighting. Let me go here. Let me go here. Let me go here. So here यहाँ पे positive charge की कमी हो गई. कमी को the lackness of. So what is positive charge? It is lackness of negative charge. Okay, charge. Lackness of negative charge. जब चार्ज लैक करता है तो होता है, देखो ये नेगेटिव बॉडी को यहाँ पे लेकर आए, यहाँ पर पॉजिटिव चार्ज बन गया और यहाँ पर नेगेटिव चार्ज बन गया. क्योंकि क्या हुआ, सारा नेगेटिव चार्ज दूर भागने लग गया, दूर भागने लग गया, इस डायरेक्शन में भागने लग गया. तो क्या हुआ, इस जगह पर नेगेटिव चार्ज की कमी हो गई और पॉजिटिव चार्ज बन गया. ठीक है ना. और उसके बाद देखो, अगर हमें इस पूरी बॉडी को पूरी पॉजिटिवली चार्ज बॉडी बनाना है, आपसे ये क्वेश्चन पूछ सकते हैं पेपर में, जो कि अगर आपने इस पूरी बॉडी को पॉजिटिवली चार्ज बॉडी बनाना है, तो अर्थ द ग्राउंड, it is considered as a neutral. It can take any charge and let it, like it is a positive conductor basically. Earth is considered as the conductor. It is the very good conductor. It allows you to take in the charge. So it takes all the negative charges and leaves it positively. So that means ground can take all the negative charges, being a conductor, and allow you to have a fully positively charged body. I hope that was a very good thing for you to learn. Okay. Now we need to learn some basic properties of charge. We'll learn about basic properties of charge. I know, guys, this is a very basic lecture. You guys know half of it. I'm just trying to give you a gist of what's going to come ahead. It's going to be way harder. And the next time we are going to use more examples. I'm going to explain you even deeper, I promise. For today, just we are trying to make a lecture out of it. And we are trying to explain you basically additive, quantization, conservation. This is the last topic for today's video. We are gonna see what are the properties of charge, and from the next time we are gonna do conservation of charge. We'll do today. From next time we are gonna start with Coulomb's law, and this chapter will be in 4 parts. And for the first part, this was just an introduction. Next part will move way faster than this. We'll try to do more. Today, I just wanted to give you a an idea of what it is. So let's continue. Additive nature. What is additive? Basically, clear with the name, charges add. Charges add if there are n charges. Okay. If this is a body, it has plus 2e, minus 2e. What is the net charge of this body? So the q net. Charge is represented by q. Charge is represented by q. Q is represented for charge. Okay. So yeah, so net will be 2 minus 2, that will be 0. So this is a neutral body. So if someone asks you what's a neutral body, you can say when the positive charges and the negative charges of a body are equal, then it's now let's say then it's a neutral body. Let's say I had a plus 1e. So I'll do plus 1 and then the net charge of the body is 1e. 1e, you have to write e. Basically every e is how much? I told you in the beginning, charge is measured in Coulomb, right? So 1 E is 1.6 into 10 raised to power minus 19 Coulomb. So 2E is 2 6 are 12, 2.2 and 3.2 into 10 raised to power minus 19 Coulomb whenever I'm taking. That's how you have. See how small it is. How small it is. Magnitude of 1.9. So yeah, we are coming there. We are coming there. Okay. So additive nature of electric charge. Like mass, electric charge is a scalar quantity. I guess you'll have learned this by now. Electric charge is a scalar quantity. Why electric charge is a scalar quantity? Because it can move in a direction, or it can either have a direction or it can have a magnitude. Sorry, it can only have a magnitude, because if it has a direction and a magnitude, then it will be a vector quantity. But charges, see, for example, I said that the last line. For example, I have a charge. It has a charge of E, let's say E, and I through an magnetic field, I accelerate this charge. Okay, I bring acceleration to this charge. Let's say electron, if it's an electron. Okay, so through magnetic field, I bring acceleration to this charge, or a proton, or anything. So see, it has a magnitude, like it is 1 E or something, and it has a direction, that it is moving in this direction. So then it can be a vector quantity. But if we are talking about general charge on a body, then it's a scalar quantity. Okay. So just as the mass of an extended body is the sum of masses of individual particles, so basically what they want to say is charges are like mass body. For example, if this is a cart, okay, and we have a horse. Okay, guys. So please ignore my drawing. I suck at drawing, but yeah, I hope you guys can get a gist of it. Okay, just ignore my horse. Okay, so this is our horse. Okay, and this is his hair, and this is his punch, and this is the happy horse. He's happy. Okay, so if he has 1 kg to take, he's happy, right? So if it has 1 kg, so the total mass horse has to carry, it will be the mass of this sledge and the mass of this, right? Same as with the particles. If there's a body and it has just E, 1 E, so the total charge it has to carry is 1 E. Okay, let's say if I put 100 kgs, oh, this horse is like sad. He's like, what the fuck, man? Just leave me, man. What are you doing? So yeah, that's the thing. He's like shouting, like crying. So, so the total mass he has to carry is 101, both the and the mass of the sledge. And the same is with the body. If we have 2E, so the total charge it will be 2E. So if it has minus 1E, then it will be minus 1 plus 2E, then the net charge will be 1E. Now see why it is like that, minus E and 2E. Basically, minus and plus indicate what is the behavior there. Say, let's say a body has plus 2E here and minus 2E here. That means this body looks like this. This body looks like this. Here there's more negative, here there's more positive. Okay, the amount of positive charge here is more, the amount of negative charge here is more. So basically, it's the same thing only. So if I say, if I add this two, it becomes a neutral body, because plus has a minus, every plus has its minus. So it is a basic in general, it's a neutral body. So yeah. And what is quantization of charge? What is quantization of charge? Then this is the second property. What is quantization of charge? Quantization of charge means that the charge, it exists in n numbers. That means it can't be rational. It is only integers. Rational not possible. It is only integers. Charges are integers, but that is not true if you go in quarks. So quarks have a charge of plus 2e by 3 e and 1 by 3 e, or a minus, or maybe plus minus, I don't know. It can vary. So the quarks, they exist in pairs, up quark, down quark, order quark, and anti-quark. So they have, but in general physics, on the physics and the classical physics, you can say, or the normal modern physics, basically what we do is we take it as quantized. A charge is quantized. That means that it cannot be very continuously to any arbitrary value, but can change this continuously to take on a Ski value. For example, a building can have different floors from ground floor upwards. Thus, the energy of an electron and atom or electric charge is quantized. The minimum amount of which, see, it says it cannot have a floor with a value in between. This is the hint you need. Like it can be, it can't have a charge 2 comma 5. Oh, sorry, in 2.5 E. Okay, that's not possible as a charge. So yeah. So yeah, guys, that's basically it for today. If I talk about the conservation of charges, so what's the conservation of charge? Conservation of charge means that charge cannot be created, like matter cannot be created, same way charge cannot be created. If there's 2e, it can't get into 3e. Like one electron will not come from, like God will not send one electron. Okay, there has to be external source to it. For this equation to be, this E should come from an external source. It can't just exist. Okay, and the total charge of an isolated system remains constant. For example, let's say this body, it has 2e as its charge. If this body has 2e, if I don't let any external source allowed to touch it, or if I don't do anything, if I don't touch it or do any force comes on it, then the charge of this 2e will always remain 2e. This is the law of conservation. Law of conservation states that an isolated body or an isolated system remains constant, and the electric charges can neither be created nor be destroyed. They can only be transferred. They can only be transferred. They can only be transferred from one body to another. Oh, I'm sorry. They can only be transferred from one body to another. This is very important. Can come in your paper. Okay, guys, let's do some examples. Also, we need to learn the formulas. We need to learn the formulas. Which are the formulas used? Charge. Q is N times E. What is N here? N is the quantized charge. N is the quantized number of charge. For example, what is the charge of body? What does this equation say? What is the charge of a body? What is charge on a body? Let's say this is the body which has plus 2E, 3E, minus 7E. Okay, let's say this is the body and we need to find the Q. So what's sigma Q here? Sigma Q is NE. Okay, so basically, how do we need to find it? The sigma charges. So let's say the first charge here, this is Q1, this is Q2, this is Q3. Okay, and if I need to get the values, right? So sigma Q, that will be NE for the first charge. So Q1 plus Q2 plus Q3, right? I'll remove this just by these. Okay. So Q1, what is Q1? Q is NE. So Q1 will be N1 times E. So N1, let's say that's 2E. So that will be 2E plus Q2. Q2 is 3. Okay. So that will be 3E plus Q3. That is minus 7. That will be minus 7E. So that's 5 minus 7. So the net charge on the body will be minus 2E. Okay, I can put the value of E, that's 1 comma 6, sorry, 1.6 into 10 raised to power minus 19 Coulomb, and then I can get my answer as minus 3.2 into 10 raised to power minus 19 Coulomb as the net charge on the body. And what is the mass of electron? Very important. 9.1 into 10 raised to power minus 31. You guys need to learn this. It's very important. You guys can solve these questions if you want. I'll do this in the next video. I'll solve the NCRT questions, both of these in the next video, as well as we'll go ahead with the topic. And I hope we'll solve all these questions in the next video. So I hope you guys enjoyed this video. It must have been long, and I'll see you guys in the next one. Thank you for watching and keep loving, and sorry for late.